going to be talking about reference angles today. Reference angles are angles that are in the first quadrant and the first quadrant only. Okay, so anywhere between, but not including, between 0 and 90 degrees. So theta is greater than 0, but it's less than 90 if we're talking about degrees, or my favorites when we're talking about radians, anything between 0 and pi over 2. So let's get started. Let's start out some degrees. 170 degrees. The reference angle, in other words, what first quadrant angle shares the same characteristics as 170 degrees? Well, 170 degrees is a rotation like that. Well, rotation like that has a reference angle of 10 degrees because we're 10 degrees from here. So if you think about if I would make 10 degrees right here, right, if I call that 10 degrees, these guys, when we're talking about the outer edge of a circle, here comes my circle. Oh, that, you're all set. That was a great circle. Semicircle. That's phenomenal. Let's just look at that for a little bit. That was really good. Oh, wow, good. Okay, let's move on here now. So these guys have some x and y coordinates. Well, this guy's got the exact same x and y coordinate with one exception. We're in quadrant 2, so my x value is going to be negative. So that's why the reference angle for 170 degrees is 10 degrees. It shares the same x and y values, but not the signs. If that makes sense. Values, numbers maybe 2 and negative 2 are the same number, but the values are different. However you want to look at that one. All right, so what are we doing there? How do I get 10 degrees? Well, we know half a circle is 180 degrees. Likewise, let's say I'm looking at 5 pi over 4. All right, well, 5 pi over 4, and a big part of this is recognizing where things are located. I like to do it like this. This is 0 pi over 4. This is 4 pi over 4. This is 2 pi over 4. So 0, 2, 4, this is 6 pi over 4, which means 5 pi over 4 is right in here. And 5 pi over 4 is, you got it, pi over 4 away from the nearest x-axis. So it shares the same properties as pi over 4 does right here. With one exception, x and y, in this case, of course, in the first quadrant are always positive, but here they are both negative. Okay, those are reference angles. You're always referring back, what is the first quadrant value? And you always, always, always do this to the nearest horizontal axis, the nearest x-axis. Never do you go to the y-axis. Okay, never. Always the nearest x-axis. You're always subtracting 180 or finding how far from 180 or how far from 360 or 540 or 720 or negative 180, negative 360. All depends on the direction if you're in degrees. And then if you switch to radians, it's always like a 4 pi over 4, right pi? 3 pi over 3, 6 pi over 6, 8 pi over 8, or maybe it's 2 pi, 6 pi over 3, 8 pi over 4, 48 pi over 24, whatever the denominator happens to be. You guys are experts with fractions. Common denominators are key, but more so being key is recognizing that you know your unit circle starts at 0. And I'm making motions with my hands here. I'm rotating around to the left. The left side's at pi. Keep going around, you're at 2 pi. Okay, and referencing all that stuff. You need to be able to make a mental image of that, and it's very helpful if you can do so. So that was reference angles in a nutshell. Have a nice one.